Hey everyone and welcome. Today we're going to dive into the world of fractions and decimals. I know, sometimes they can seem a little tricky, but I promise we're going to make this super simple and fun. By the end of this, you're going to learn a special trick. It's like a secret code, really, that shows you exactly how they're connected. So let's get started.
So here's what we've got lined up. First, we'll find out that there are two main kinds of decimals. Then, we'll meet a really special one called a repeating decimal. After that, I'm going to show you my absolute favorite math magic trick. And to wrap it all up, we'll get to practice everything we learned. Sound good? All right, let's jump right in. Okay, so first things first, whenever we turn a fraction into a decimal, all we're really doing is dividing the top number by the bottom number. But, when we do that division, one of two things is going to happen. Let's find out what they are.
So you basically get two kinds of decimals, finite ones and infinite ones. Finite is just a fancy word that means it has an end. Think of it like a story with a final page. It just stops. A finite decimal is exactly like that. It stops dead in its tracks. And then you have infinite decimals. You guessed it, infinite means it goes on forever. These numbers just keep on going and going and going.
Let's look at a real example of a finite decimal. If we take the fraction 3 over 8 and we divide 3 by 8, we get 0.375, and that's it. The number ends right there with the 5. It just stops. Nice and clean, right?
Now what about an infinite one? Well, if we take 2 over 3 and we divide 2 by 3, you'll see your calculator screen fill up 0.66666, and it just doesn't stop. Those sixes would go on forever if they could. That right there is an infinite decimal.
So that last one we saw, the 0.666, that's actually a super special kind of infinite decimal. See, it's not just a bunch of random numbers going on forever. It has a pattern. These cool decimals are called repeating decimals, and we're about to get to know them a whole lot better.
Okay, so what is a repeating decimal officially? Well, it's an infinite decimal where a number or even a whole group of numbers repeats over and over and over again. And that part that keeps repeating, it's got a name, the repeating part. So for 0.666 repeating, the repeating part is just 6. It's the piece you see again and again. Pretty simple, huh? Now, who wants to write 666 forever, right? Nobody. So mathematicians, being smart, came up with a shortcut. Let's look at this chart. For 0.666, the repeating part is 6. So for the shortcut, we just write 0.6 and put a little dot right on top of the 6. See that? That little dot is our secret code that means this number goes on forever. Easy. Okay, next one. 0.363636. The repeating part is 36. So we put a dot over the 3 and a dot over the 6. And for the last one, 7.215215. The pattern is 215, so we just put a dot over the first number, the 2, and the last number, the 5. It's a great little time saver.
Okay, this is where it gets really, really cool. What if I told you there was a secret way to just look at a fraction and know instantly if its decimal is going to stop or if it's going to repeat forever? No calculator, no long division. It sounds kind of like a magic trick, doesn't it? Well, it is. And now, welcome to the Magic Show. In this section, I'm going to teach you the secret code that connects all fractions and decimals. Get ready, because you're about to be able to predict the future. Well, the future of the fraction, anyway.
Every good magic trick has steps, and ours has 3 really simple ones. Step 1. Simplify the fraction. Seriously, you have to do this first. It's the most important part, don't forget it. Step 2. Look only at the bottom number, the denominator. For this trick, the top number doesn't matter. And step 3. Break that bottom number down into its prime factors. Prime factors are just the basic building blocks of numbers, like 2, 3, 5, 7, and so on. All right, you're ready for the secret? Here's the first half of the rule. Once you've broken down that bottom number into its prime factors, if the only numbers you see are 2s and 5s, then bam! The decimal is going to be finite. It will stop. That's the big secret. Only 2s and 5s means it stops.
So, what happens if another number crashes the 2s and 5s party? Well, if you find any other prime factor down there, it could be a 3 or a 7 or an 11, anything else, that is our signal. It means the decimal can't stop cleanly. It's going to be a repeating decimal and go on forever in a pattern. That's the whole trick.
Okay, talk is cheap, right? Let's actually use this new magic trick and see it in action. It's time to put our new skills to the test with a couple of fractions.
First up, we've got the fraction 7/20. So step 1, is it simplified? Yep, it is. Step 2, look at the bottom number. That's 20. And step 3, find its prime factors. Well, 20 is 2 times 10, and 10 is 2 times 5. So the factors are 2, 2, and 5. Now look closely. Are there any party crashers? Nope, it's only 2s and 5s. So what does our magic rule say? It's going to be a finite decimal. And what do you know, if you check it on a calculator, 7 divided by 20 is 0.35. It stops. The trick works. How cool is that?
Let's try one more. How about 4/15? Okay, step 1. Is it simple? Yes. Step 2. The bottom number is 15. Step 3. What are the prime factors of 15? Well, that's just 3 times 5. Uh-oh. See that? We've got a 5, which is fine, but we also have a 3. That 3 is our party crasher. So our rule says it's going to be a repeating decimal, and if you check it, 4 divided by 15 is 0.2666, and on forever. See? The trick never fails. So, okay, this is a really neat trick, but why does it actually matter? Well, for one, it saves you a ton of time. It's so much faster than doing long division. But more than that, it helps you see a really cool hidden pattern in math. It shows you that fractions and decimals are linked together by this one simple rule about their building blocks. It's like we discovered a secret code that was hiding in the numbers all along. So what's the big takeaway here? It's that every single fraction has a secret identity as a decimal. And that decimal either stops or it repeats forever in a pattern. And now you know the secret code to figure out which one it's going to be, just by looking at it. No calculator needed. You all did an amazing job today. Thanks so much for learning with me.